Assalamu alaikum students. Today we will discuss the second topic of the 10th class book, that is ball and bowl system, which is also an example of simple harmonic motion. In the previous lecture we discussed the example of mass attached to a spring, and we proved that mass attached to a spring is an example of simple harmonic motion. Simple harmonic motion, we also discuss in that simple harmonic motion is a kind of a vibratory motion in which a body moves to and fro or back and forth about a mean position of a body. In today's lecture, we will prove that ball and bowl system also obeys the motion of simple harmonic motion. In today's lecture, we have a system that is ball and bowl system. Here it is a bowl, and in the black color I have shown the ball. When we start this experiment, the ball will be at the position O. This is the position O, known as the mean position of the body. The motion will start about its mean position. In this position, the reaction force and the weight of the ball both are equal, that is W will be equal to R. R is the reaction force, normal reaction force, which is in upward direction, and the weight of the ball is in downward direction. Both are equal in magnitude but opposite in reaction. That is why the net force at the position O will be 0, hence there will be no motion at the mean position. But when we move the ball from O to the A and we release the ball, then the ball will start moving toward the mean position. This position A is the extreme position of the ball and bowl system. A is also the extreme position, as well as the B is also the extreme position of ball and bowl system. As we release the ball from the A, can you tell me which force will be responsible for this motion? Yes, the restoring force will be responsible to move this ball towards the mean position. Actually, the weight of the ball generates the restoring force, due to which the ball will start moving toward the mean position O. As the ball move from A to O, it will not stop at the position O. Why? Students, because we learned the term inertia in 9th class, that inertia want to continue the motion of the ball. So the motion of the ball will continue from O to B. When we release the ball from A, the acceleration of the ball is also towards the mean position O. But due to inertia, it will not stop its motion and the ball will go toward the mean position B. At the position A, the velocity I have mentioned in the diagram is 0 because the ball is at rest. So it is not moving, hence velocity will be 0. But when we release this ball will start moving, hence its speed will be increasing. Its speed will increase, it will start increasing, and it will move toward the mean position O. At the position O, the velocity will be maximum. At position O, the velocity of the ball will be maximum and its acceleration will be 0. But when the ball crosses the mean position, its velocity starts decreasing because it is covering the height. It is covering the height. The friction will oppose it, hence its velocity starts decreasing. At the point O, it will remain rest, it will become rest for a second, then it will start again moving toward mean position O due to the restoring force. Hence, the velocity of the ball at B will be 0 and its acceleration will be maximum. Moreover, I haven't mentioned about the potential energy, so I am mentioning that potential energy at the point B will be maximum because it is at the maximum height. Moreover, at mean position, the kinetic energy will be maximum, and at point A, its potential energy will be maximum. So these are the energy changes in the case of the ball and bowl system. At the point B, potential energy is maximum because the ball is at maximum height. At kinetic energy is maximum at the mean position because its speed is maximum. At the point A, the potential energy is again maximum because it is at the maximum height. Students, you are noticing that when the ball is moving from A to O and then to the B, its acceleration is always towards the mean position. It is due to the restoring force. As we have discussed in the previous lecture, that the restoring force is a force which always pushes or pulls a body performing an oscillatory motion towards the mean position of a body. So it will always try to move the ball toward the mean position bow. So during the motion from A to O and O to B, then B to O, then O to A, the ball will start moving to and fro unless and until friction will start opposing this motion, and a stage come when the ball again stop towards at main position O. So this to and fro motion or oscillatory motion of a ball from A to O, then O to B is a type is a kind of oscillatory motion, and it is also simple harmonic motion. In this case, we want to prove that the ball and bowl system is also an example of simple harmonic motion. So there are four conditions in which we can prove that the ball and bowl system is a simple harmonic motion, which are given at the page number 5 of your book. Number 1, a body executing SHM always vibrate about a fixed position. So in this case, the fixed position in this case is at O, which is the mean position. So the ball and bowl system is an example of simple harmonic motion because it is vibrating about a fixed position, and that fixed position is the position O. The second condition in the book is given that its acceleration is always directed toward the mean position, and you can see in the diagram that I have mentioned in that acceleration of the ball is always towards the mean position. So second condition of simple harmonic motion is also satisfied in this case. The third condition is that the magnitude of the acceleration is always directly proportional to its displacement from the mean position. Yes, you can see in the diagram that the acceleration is always directly proportional to the displacement from the mean position. That is, acceleration is 0 at the mean position and acceleration is maximum at the extreme position. Acceleration is also maximum at the extreme position A, where velocity is 0. The fourth condition of the simple harmonic motion given in the book was that its velocity is maximum at the mean position and 0 at the extreme position. You can see in the diagram, students, velocity of the ball is maximum at the mean position O, and it is minimum or 0 at the extreme position. So all these four conditions are satisfied in the case of the ball and bowl system as well as in the case of mass attached to a spring. Whenever these conditions are satisfied, students, it's mean that the motion of the system is an example of simple harmonic motion. So we have proved that ball and bowl system is also an example of simple harmonic motion. Now we will discuss some terms related to it. For example, vibration, which we will have also discussed in the previous lecture. The second one was the time period, the third one was the frequency, the fourth one was amplitude. I will discuss one by one. Number one, vibration. Vibration, one complete round trip, like when I start the motion of the ball from A to O to B, and then the ball when again comes to O, one vibration is completed. So one complete round trip about a mean position is called one vibration. So one vibration is from A to O to B, B to O, and then back to the A. This is the vibration. Time required to complete one vibration means when I release the ball from A and the ball again returns to the A. The time during this vibration is known as the time period, and the unit of the time period is, students, second. Frequency. Frequency is the number of the vibration in 1 second. For example, in 1 second, the ball and bowl system complete two vibrations. So its frequency will be 2 seconds. The maximum amplitude of the vibrating body on the either side of the mean position is called amplitude. So this is the amplitude of the vibration. Means, for example, if the ball is continuous its motion, its amplitude start decreasing unless and until its amplitude will be zero at the mean position. So students, in today's topic we have proved that ball and bowl system is also an example of simple harmonic motion. Students, your task is to uh, learn the topic ball and bowl system and write its conditions, its four conditions which proved that it is an example of simple harmonic motion. Moreover, you have to draw this diagram on your notebook, label it. This is the homework of your this is the assignment of your today's task.